Hey everybody, good. This time is good afternoon. Hi y'all. I hope you enjoyed your lunch. Thank you, Jorge. Yup. Good afternoon. And I'm letting a few more of us in. Second. Let me just update this. All
Hey,
right.
Miss
Cool.
Ivano.
Hey. Hope you're doing well. We got. All right, y'all. Let's go ahead and jump into our check-in question. So today, let's check the date. Yep, today is January 12th, Tuesday. My check-in is, how would you like to spend your free time in this new year? Probably like giving yourself more time to do something you probably didn't have as much time for last year. So yes, it's still kind of fresh, us being in the new year. So like, what's kind of something you want to make more time for in this for your free time? And in a second, I'll be reading that. All right, we have some good stuff. Let's see, we've got money, sleeping, making some money, making money, drawing, finding new ways to make more money. All right, we got two people who are trying to, increase the bucks, brushing up on old skills. Two for reading, crochet. I think I'm saying that right. Is that crochet? And learning ways to advance crochet skills. That's awesome. That's a good, I mean, I have a crocheted what's it called, tissue box. That's what it is, and it's really cool. Reading and learning more about politics, baking, learning how to play a new instrument. That's amazing. Reading some new books, reading, cooking, and then doing my hobbies more often, exercising more. Yeah, I think I for sure, I'm gonna side with you, Jorge. I That's one of my New Year intentions. Trying to get some exercise and movement in. It includes me standing instead of sitting. I also was realizing that was really hurting my back to be sitting. So as you can see, I'm kind of standing here. I will sit though, because it's gonna be hard to stand all day. But yeah, so trying to get some more exercise in. For those who just came in, if you could quickly answer our check-in question so I could double check you in here. See who just came on in. And then I'll go ahead and announce who I'm missing. And then please correct me if I'm wrong. But this is who I don't see yet. Okay. I don't see Tyree, Dennis, Janet, Jose, or Marvin. I feel like I saw one of, yeah, Marvin is here. So I'm missing Jose Juarez, um, Alicia. I'm missing Marco and Bianca. So let me know if that's correct or if you're here. No, I have Bianca. Sorry. Bianca's here. So let me go ahead and go over this. So I'm missing Tyree, Dennis, Janet, Jose, Alicia, Marco, and that's it. So that's who I'm missing. If you're friends with any of these peers, feel free to send them a text to come on into class. Otherwise, let's go ahead and transition. So yeah, I'm hoping we all get to have more time in this new year to kind of do those things we want to make some more time for. And let's fill this in. Oh, I think we got Tyree. Welcome, welcome. All right, y'all. Let's go ahead and get started. Oh, okay. I saw some more. Oh, playing video games, chilling. I do a lot of boxing, but I want to get into the habit of running, even though I hate running. I agree with you. Likewise. Fly through different dimensions on a massive eagle with laser eyes. Hey, if it's possible, let us know if that that works out, Miles. All right, so let's jump into our agenda today. So as y'all know, yesterday we kind of left off the investigation, but we didn't yet tie up the big ideas yet. I just showed it, and talked a little bit about it, but we didn't like get to interact with the big ideas yet. So that's what we're gonna do. We're gonna wrap that up, and then Sorry. And then we're going to have an individual lesson with limits on Desmos. So this is individual. This one's not a group. And after that, some big ideas. But I'm pretty sure that we're not going to finish up our individual lesson though. But we'll see. We'll see how far we get through it. Yeah. Oh, yeah. And async number 2 is due and posted. Yes, some of you mentioned and messaged me saying like, oh, it's saying something about tables. We haven't talked about that yet. So tables is actually what we're going to be talking about today. And even if you don't know how to do it, you could click on the Get Help button on the Khan Academy, and it walks you through the steps on how to get the solution. So just like as a tip there for asynchronous number 2. So you can always get the solution and just kind of study there on how they did that as well, in case you wanted some feedback on that. All right, and I'm so sorry for my noise background, by the way. I'm having a lot of stuff going on over here at home, so hope you all understand. There's like a coffee maker going, so okay. All right, so here we go. Let's get on with it, y'all. So, all right, so recap, y'all. Recap. So yesterday in our group Desmos, we talked a bit about what it means when the limit exists or doesn't. And I even started off yesterday's lesson with a little clip from the Mean Girls movie. And she said something like, oh, if it doesn't approach anything, the limit doesn't exist. So that's kind of like a slight truth, but we want to be very precise in our definition. So when Benny and Bertha do meet up, basically the limit exists. And sometimes they don't meet up, right? And when they don't meet up, that's when the limit does not exist. So for example, here, the limit at x equal 3 does not exist. But we can define one-sided, like, oh, I know Bertha's coming in from the left here, Benny's over here. We can define one-sided limits, but if I was to say, hey, does a limit exist right here? We're gonna say no, because the bugs don't end up meeting. And then give me 1 second. All right, let me know if anyone has any questions about our recap. But if not, again, we're gonna go ahead and jump back into our big ideas. But remember, we're not copying down notes this time. Remember what I mentioned is our new process. What we're gonna be doing is, and let me show you once more. I'm gonna probably be showing this multiple times. You're gonna go to our Google Classroom. And what you see right here is, you see asynchronous 2. You see our group Desmos right here from the other day. That's not happening today. And down here is where you're gonna see our slides. So I'm gonna go ahead and move this all the way to the top so that it's at the top for you. So as you can see, it's now all the way at the top of my stream. And where we're at is right here, Q3, day 3, wrap up plus limits with tables. So you're gonna click on the presentation, you're gonna make your own copy, and you're just gonna do annotations instead of copying down paper notes. So that's what we're doing. Instead of actually writing down our notes, you're just making a copy of today's slides. So let me give you a moment to do that. So let me put that in the chat for the directions. There you go. I went ahead and just put the directions again. So I see 4 of us popping in there. Awesome. So once you're in there, just go ahead and make your own personal copy. And then on there is where you're just going to follow along and annotate with us. That's going to be like, where all your notes and everything go. And for those of you who are like really organized on Google Drive, you could stick all of the note slides in one folder, and if you move it to a folder on the drive, I could show some of you if you're interested. Um, right after this class, I have my office hours. So if anyone's interested in organizing, putting all your notes in a folder on your drive, I could totally help with that. But that's what we're doing instead of copying down notes. So you definitely want to be here with us. All right. So I'm right now on slide number 6 on today's slides. And this is what we're going to be taking a look at from yesterday. So again, I'm going to kind of go over this once more. So yesterday's investigation with your group, Bertha and Benny met up at the same Y value. So yesterday, I think they met up, they met up at the Y value of Y equals 2 right here. So that means there was a left-hand limit coming in from the left of 3, and that equaled 2. And there was a right-hand limit coming in from the right of 3, and that was equal to 2. Because the left-hand limit and the right-hand limit are equal, we left off with saying we can drop the plus or minus sign. And we say that in this scenario, the limit does exist because they made up at the same location. And day 3, so we're on notes day 3. So slides day 3, there we go. Yeah, just make your own copy. That way it's gonna save us time. So we're not just writing down word for word. It's like, you don't have to do that if we have our slides here for you. So you could always go back to the slides and you could just make yourself little comments and annotations as you go along. All right, y'all, so you're ready for our first participation point. So this was, you're gonna be having some participation based on this here slide number 6, and we have a Padlet for it. And we're gonna keep coming back to this Padlet right now for this point in time. So let me put this into the chat and then I'll go over some directions right now. So go ahead and click on the Padlet. Now for this part, it's super important to follow the directions because we're going to be getting credit for this part. This is our participation credit. So what you're going to be doing, we're here on the first column. So there's actually separate columns. You're all going to be writing on this side where it says a little plus right here. You're going to click on it and you're able to write your comment. If your name is not popping up at the top, please make sure you put your name or initials for your credit. Everyone's going to go ahead and answer this first question. And I even put the screenshot there for y'all to reference it. So the first thing is, in your own words, explain when we don't need to write a plus or minus symbol after the number below our limit. So that's what we're right now checking in on. And you could review this slide, but in your own words, when can we drop that plus or minus symbol? So good, I see a few of us are on here. Notice how if I scroll down, we can see everyone's contribution. Again, this is for participation. Let's go ahead and have about a minute or two, and then we'll read some of this. Let me put the directions in the chat again. All right, I hope I gave everyone enough time there. I don't see anyone else writing. So let's go ahead and check out what you all thought about this first big idea check-in. So when can we drop that plus or minus sign when we're writing our limits? And so let's take a look. And I really liked it as I was kind of scrolling down here, the different language that we're using and the different ways that we're understanding. So we could see right here, this one's mentioning we drop it when they're equal. Um, and this one's when they match. So like matching, like a different word for saying they're equal. I like it. And then including the fact that what does that mean about the limit? Does means it does exist when they match. And let's see if there's anything else. This one's when they are equal. And I know there was a separate miles down here. So good. So again, there's the equality when they're equal. I know there's different ones. It says we can leave out the plus and minus symbol once we know the left and the right limit. So I like that one because you need to know what the left and the right limit are in order to determine if the limit exists. So I like that one. This one's when both limits match. This one's differently worded, so I like it again. Plus or minus because the dot isn't moving in one direction. And I'm just trying to figure out if there's anything different that was said, but most are in agreement here. Well, I like this when they meet. So kind of like your graph is connected and they meet. It does say anonymous though. Make sure you put your name here. Oh, I see it. Never mind. I see your name. All right. This is looking great. Again, make sure you put your name and make sure you put your check in on that big idea. Number one. Let's go ahead and move on to the next big idea. That was my copy. Sorry, the next kind of elaboration of our big ideas. Remember, we're not copying this down anymore. You're just kind of taking a look at your own slide copy. So remember this scenario. We kind of started off talking about limits with Benny and Bertha, and they were trying to meet up, and they kind of had this kind of graph where the graph kind of had a gap in it, like so. Like there's a little jump there. Unfortunately, the bugs can't jump to meet each other. So some things to consider are, what does it mean when the bugs don't meet up? When the left and the right hand limit are not equal, that means the limit does not exist. And again, this is going to look like a gap or a break in your graph. So again, when you have these two like so, in this scenario, this is what you would write. You can drop the plus or minus, as you can see, but because 1 clearly does not equal 5, we put does not exist. And we write this as D and E. That's how you would write the answer to a limit that does not exist. So that's huge on how to apply that. Ooh, okay. Yeah, I like Francisco what you put there. And I think you could totally put that same thing there on our Padlet because that's our part 2 check-in. So Francisco put the Y value is different. So the limit does not exist. Yes. And then here's just some more clarity. Since the left and the right hand limit do not meet up, we say the limit does not exist. This is shorthanded as D and E. So y'all can pause and take a look at this, continue to let this sink in. For those who are ready, go ahead back into that Padlet. So don't close up the Padlet. It's also still in the chat. And you're gonna go to check-in question number 2. And let me show you. So back to our Padlet right here. In your own words, when can we use D and E? So how do you know when to use D and E is my question to you. And this could be different for everyone. So you could go ahead and write down your thoughts on this on big idea check-in number 2. And again, we're not copying down notes. We have our own copy. So we have kind of more time to engage with what's on the slide rather than just copying things down. Let me give you all like a minute or two to fill in the check-in question number 2. Let's see.
Miss Adana, I have a question.
Oh yeah, of course. Go ahead.
So the participation, is that what we do on Padlet, or we also have to take notes on the actual slides that we made a copy of?
So today I'm not going to be collecting notes. So it's up to you. So today, y'all, it's up to you. You do not have to copy this down. So our participation today is going to be the Padlet and what we get started on the individual Desmos. So yeah, so up to you today if you want to annotate your slides. Not required today though. But yeah, up to you. You're free to if you want to make yourself little notes. Hmm. All right, I'm gonna give us a few more seconds there. I was just trying to pinpoint different answers that I'm taking a look at, and these all look varied to me, but they're all on point. So these are all like different ways to kind of rephrase our understanding. So I'm seeing this as more like worthwhile for us to kind of engage with the big ideas. Uh, you know, better use of our time. Okay, awesome, y'all. So again, make sure your comments in there. You could totally let me know if you have any questions or any issues with this. So great. So I'm noticing a lot of similar things. So the similarities I see is a lot of you are mentioning when the Y values aren't equal, which is correct. A lot of you, I like this, mentioning the left and right limit, kind of just adding the one-sided limits in there. Um, let's see what else we have. Some are using the bugs still, like when the bugs don't meet up, meaning the limit are equal. So they're kind of making connections to like that scenario where we had the bugs meet up. There was another one I really liked it. Where was it? Yeah, this one. It was Henry's right here. um, I like that he thought of this in graphical way. So he said, when the graph visually looks broken, or as if it suddenly jumped. See how that's very different from what was said before, but it's also correct. So I kind of like that there is a variation. Here's a question, I think, and totally fine to ask some questions. And you could totally like, if you have a question, you could take a look at what other people said. Yeah, and this one incorporates that gap in the graph as well as saying left and right are not equal. So that's would make a very strong justification. I like how this one interprets what DNE stands for and then goes on from there. Again, gap in the graph is mentioned and Y values. Yay. All right, y'all. So thank you so much for engaging there with our big ideas. I don't know why I have two slides open. So let me go ahead and go back here. So now we're going to jump into application. Now for this one, again, you do not have to copy it down because we have it here on our slides. But of course, if you want to copy this down, it's up to you. But again, you all have your individual copy. I don't know. Y'all hear that plane? There's a plane back here. Okay. Let's try to apply this to kind of a general math problem. So again, because we're not copying this down, we're just going to go ahead and jump into it. Take a look at this first example application. I gave the limit as x approaches 3 from the right. It's the first problem. Then we have the limit as x approaches 3 from the left. And then we have the limit as x approaches 3 without the plus or minus symbol. So let's see how we're going to address this. So first, let's take a look at our graph. It looks pretty smooth and connected until there's like a hole here, and then there's a dot. So this hole right here means that the function is not defined at that point. It's defined up here. But that's irrelevant, right? Because you still want to imagine there's bugs walking. And the bugs can't jump up to this point. All right, so step one. What I like to do is I always like to kind of just below the limit, I kind of just write myself what it means. So because there's a plus there, I'm going to I'm going to say that this means it's approaching 3 from the right. The next step I'm going to do, I usually like to draw a vertical line down through the x value. Because we're talking about the x value of 3, I'm going to draw a vertical line down. And yes, it's a little bit crooked, but I put a line there. So it's down straight through 3. The next thing I do is I'm going to label the left-hand side of my graph and then the right-hand side. And you all are able to kind of, do this like with the slide too if you hit present. Okay, so then if we kind of imagine a bug approaching 3 from the right, let me pretend like I'm drawing a bug. So I'm going to use bugs here to kind of demonstrate the point. So I'm going to place the bug right here because it says it's going to approach from the right. That means it starts on the right-hand side. So here's my bug. Yeah, she's kind of floating. Let's say this is Bertha. Okay, so Bertha is going to be walking along this curve, and Bertha is going to have to stop once she hits the x value of 3. So she's going to continue walking and walking until she hits that x value, and we're going to see how high Bertha is at as far as the y value is concerned. So Bertha is going to stop right here on top of this point. So there is where Bertha is. So what do y'all think the limit as x approaches 3 from the right in this problem is going to be? So where does Bertha end up in this point? All right, a lot of you are saying, 2 of you are thinking 2. All right, you both are correct. Oh, do I not write 2? Wow, I didn't write 2. So yes, the answer is indeed 2. You're correct. Awesome. All right, so we answered the first limit question. So I'm gonna just delete Bertha here. And now we're going to do, let's just say Benny's on the other side. So Benny is gonna be starting on the left-hand side. So I'm gonna put a bug randomly anywhere on the curve on the left. I just put Benny all the way down here. You could put Benny really close up here too. So Benny's gonna walk along this curve and he's gonna keep walking until he ends up right where x is equal to 3. And then Benny's gonna be right here. And now where does Benny end up at? All right, Miles is thinking 2. Let me know if anyone disagrees with that, but that is correct. So Benny coming in from the left is going to also come into 2. So because the limits are equal, AKA because the bugs are going to end up meeting, what is the limit as x approaches 3 then? Yeah, the limit is real. That's true. And then Miles says it's 2. And then Francisco agrees. You all are both correct. The answer to the limit when you drop the plus or minus here is going to be 2. And this right here means the limit exists. Again, because they meet up. Because the graph does not have a gap. I'm just trying to incorporate some of the stuff y'all were saying in the Padlet. Because they meet up, the graph does not have a gap. The left and right hand limit are equal. And I forgot what else y'all said. So what I'm doing right here is I'm just kind of adding all the different justifications you could say as to why the limit is actually 2. And this I'm taking from the stuff y'all mentioned there on the Padlet. Let me know if anyone has any questions. Let me pause here. And by the way, this limit interpretation is approaches 3 from both sides, just in case if you want to write, for each one. But again, you have a copy of this. I'm going to pause for questions, then we'll do example 2. All right, y'all. So let's go ahead and move on from this one. So again, this that I put, like any little notes that I'm putting on the slide, that's something you want to write a comment as, basically. Just, do a little quick comment, and then we'll jump into the next thing. Again, I'm not collecting today's copy of notes. Up to you if you want to do that. I'm going to go ahead and clear my work. Now, next one. All right, now I chose a graph that has a gap in it, very similar to that first scenario, to kind of see how we can apply existence. So again, I'm going to kind of repeat my steps. Step one is I kind of switched the orientation. I usually like to interpret the problem like, okay, this is approaching 3 from the left. Step two is I like to draw a line down. And again, I don't know. Yes, it's always kind of around x equals 3, but we could choose x equals anything. Coincidentally, I just found these examples. So if I am approaching 3 from the left, let me label it. So this is my left-hand side, right-hand side. So then I have to kind of imagine that there's a bug walking starting from the left-hand side. So I'm going to place my bug here. Let's say this is Benny this way. Just a big old bug. I know. It looks like a spider. But anyway, so Benny's going to walk along this curve, and Benny's going to stop once he can't walk anymore. And he can't jump, he can't fly. So he's going to be stuck somewhere. He's going to be stuck at a certain Y value. So I already see something in the chat. You just draw him right here. So the limit as x approaches 3 from the left-hand side is going to be a y value of, let's see. Okay, looks like Francisco says a y value of 4. Let's see if anyone disagrees or has questions about that. If not, I agree with you. I could see that Benny is right here where my y value is 4. So let's go ahead and write down 4. All right. Next one is imagining a bug is now coming in from the right hand side. Now, the only thing on the right hand side is this curve down here. So we kind of have to put a bug on this pathway. And we're going to stop that bug once it hits the x value of 3. So again, once you get used to this, you don't have to draw bugs or imagine bugs. You could kind of just see how your function is behaving. Like I said, bugs are just a tool to kind of just help us understand. So Bertha is going to be approaching 3 from the right. She's starting on the right-hand side of the graph. It's like she's walking, and she's going to stop at the x value of 3. She's going to be all the way down here. Now, where is she at? All right, so 3 of you say -3. You are both correct. You are triply correct for the 3 of you who answered. So this is going to be -3. Okay, so as we can see, the left hand limit does not equal right hand limit. So what can we say for the last limit there? So this last limit says if it's approaching from both sides. So this limit is not real, it does not exist. Let's see if anyone agrees with that, disagrees. So, I mean, okay, we got 2 that says DNE. I think you all got it. And this basically ties, yes, smiles as well. So this ties into what we're talking about, right? So if the left limit does not equal the right limit, we put DNE, the limit does not exist. So now you could probably know what that movie was kind of talking about that I showed you the clip on. So DNE. And again, if you were to be asked to justify this answer, there's a variety of things you could say. The gap, the fact that the left does not equal the right, different things. And today we're going to even talk about how to incorporate tables into this explanation. All right, I'm going to pause for questions. And then if there's no questions, we're going to get a start on the next topic, which is how to determine the limit if you're looking at a table instead of a graph.
I have a question.
Yeah, go ahead.
So, is the little like circle thing, does it matter if it's shaded in or if it's like, just the circle?
That's a very good question. So the formal definition of a limit says that It doesn't matter what's happening at the point, it matters what's happening near the point. So yes, it does not matter whether it's an open circle or shaded in. So that's a very good question.
Okay.
Oh, that's a good question. Is bounded the same thing as DNE? Almost. I would say sometimes. It depends. So for those of you who did the Khan Academy practice, you probably saw something that said unbounded. So when you see something like that, unbounded means infinity. That means the limit is going to infinity because there's an asymptote there. So for those who saw that, it depends. So I would say yeah. I think unbounded is the same as DNE because infinity is not a number. So you could say infinity is also does not exist. So that was a direct question to me on a private thing. So yeah, unbounded could be mean the same thing. Like the bug is not going anywhere, which is very similar to what we saw in that clip that I showed you, the Mean Girls clip. Let's see if there's any other questions. All right, but again, feel free if you have additional. By the way, office hours is right after this class in case anyone wants some assistance on the homework or any questions on this. Just so you know, it's right after this class today. All right, let's jump into the next thing, y'all. Okay, so we're gonna get prepared. We're not doing group work today. It's an individual Desmos. We're gonna start it today, like I said. That's why I knew we weren't gonna finish it because I wanted to dig very deeply into the big idea of when the limit does not exist. But here are some things to think about to lead us into the next lesson. I don't have a video for this, but how can we use a table now to determine a limit? And how can I make connections between tables and graphs to determine a limit? So taking a look at a table and its graph, what are some things you're looking for, like to see what the limit is or whether the limit exists or not? So those are just some questions to think about before you jump into it. Let me give you a moment to just process it. Remember, we don't have to copy anything down. I know I'm saying that a lot. It's just sometimes it gets lost in translation. All right. So after we've thought a little bit about these two questions that we're going to dig into, let's go ahead and begin individual Desmos. So we are period one. So you're going to go to student.desmos.com and this is the code that you're going to type in. Let me give you all some time to get logged in. If any of you need to like pop open your laptop, you can do that. Like you could still stay logged in if you're on your phone, but like, you know, on the side, open up your laptop and log into the Desmos like that. This is going to be part two. So today's credit, just so I clarified, Padlet, and it's this individual Desmos. So let me put that in the chat. So for today's credit, that's what it is. And I'm just giving y'all some time to get in there and then I'm going to go there with you. And this is going to be kind of like a guided lesson where we explore limits and tables. So both Desmos, did I not put? Yeah, I still need to put, so both Desmos, are you talking about yesterday's Desmos, Miles? If so, I still need to put that one in. I haven't had time to stick it in. But for today's credit, oh, you're asking about these two. So right now we're just in period one, I think. So we're gonna log into the period one. Let me know if I understand the question though.
Yeah, I was asking why there was two things because I
Yeah.
have my chat covering where it says.
Oh, okay. I thought you were talking about yesterday's Desmos. No, yeah. So you just wanna, we're gonna just log into the period one, only one of them. All right, I'm gonna go ahead and join you all over there. When I go join you, it's gonna kind of, I'm gonna be doing the slide thing where you follow along with me. So let me just get out of the slides and I'm going to go ahead and join you all. Awesome. So I see how many? We have 19 of us. Oh my gosh, I think that's almost all of us. We still need about three more students to come on in and log in with us. Now, the first question is going to be a very check-in question on your energy level and how you're feeling. I just like to stick that in, to check in with everyone. So we're going to go ahead and be on that slide. Again, you want to make sure for your credit that you're logged in here with us. Let me go ahead and make this my full screen. Now what I'm going to do is I'm going to next anonymize the names. So I'm going to click anonymize. And we're going to do some pacing. So I'm going to restrict plus, there we go. Sorry, I know I forced some of you who are on slide 2 into number 1. All right, so first things first, go ahead and do a little, I thought that said Jerry Springer, it says Gene Springer. So go ahead and just graph where you're at with as far as your energy level. And it's a variety of energy levels that we're at here. So just like a quick check in there, how you doing, how you're feeling, um, ready to go to sleep. I know how that feels. I love that. Whoever the Win Su Wu put DNE. I love that. Already applying their definition into some jokes. We got some hungry, oh, feeling sad, neutral, dot, dot, dot. No, that's okay. I paid too much attention to work. That's okay. Variety. So awesome. Just take some time to do that. Then we're going to move on to slide 2. Again, this is going to be anonymous. Your name should not be revealed, so don't worry about that. It's just a general check-in. All right. Once we're done with the quick check-in on how you're doing, we're going to jump into slide 2. Slide 2 looks like this. Let me pretend I'm a student so I could see how you all are looking at this. Okay, so first off, I want you to take a look at this graph. It looks like a line, first off, but the function itself, if you look right here, looks really funny because it looks like it has a division. Maybe some of you remember functions that look like this when y'all did long division last year. I think y'all remember. This is called a rational function in case if you want to remember that. But let's say that we're trying to look at the limit of this here function as x approaches -4. So what that means is you're trying to find where x equals 4 on the x-axis, which is horizontally right here. First, I want you to put your mouse over the function like I'm doing right here. You're going to trace it. And you're going to stop when you get x equals 4 on here. And I want you to put what you notice or wonder is, oh, I'm sorry, -4, my bad. -4 is on this side. So you're going to trace your graph until you reach -4 over here. And what I want you to put is, what do you notice or wonder is happening when you go near or on the x value of -4? And then you're going to put down your thoughts. So take a moment for that part, and then we'll take a look at what y'all are seeing. Okay, I'll give a little bit more time. I see many of us are still thinking about this. Oh, let me check the chat. I'm sorry, what's the code? Oh, you got it. Okay, my bad. Yeah, code's up here in case you still need to join us. Okay. Okay, I think I still see a few of us still writing, but let me go ahead and start seeing what we're noticing and wondering so far. So far I see a lot of you. I see undefined coming up a lot. So Jean Springer says undefined. Grace, it's undefined because it's an open circle, maybe a small gap. Not sure. I love that thinking. Undefined, and then I noticed that it is at -9. And I'm wondering if you mean like the y value. Like this one, I would pray for. I mean, push for more. Specification. Do you mean x at -9 or y? And then I think this may be a limit. So maybe you're talking about the y value. But then I notice that x equals -4, the graph is at -1. But then I see these -9 popping up. So I'm interested to see how that connects with the graph. And again, many of you are noticing it's undefined. Oh, and I like this notice. You're noticing that there's these different points, some that it stops. Okay, these are awesome. Go ahead and complete your thoughts on there. And let me just go back to what you see in the graph to kind of just see where we're getting that -9 and 1 that y'all are mentioning. So I'm going to just trace my graph and I'm going to kind of just approach -4 here, like just pretending that my point right here is like a bug walking on the curve. So yeah, I agree with y'all. So once I am right on top of -4, I notice it does indeed say undefined. Now, maybe because this open circle is at the y value of -9 right here, this is where that -9 I see popping up in the notice and wonder is about. So I think that's where that -9 is coming from. Someone mentioned something about x equals 1, about it stopping there. So I have some wonderings about that. Um, and Henry put something in the chat. Oh, you can't divide by 0. Huh. What clarify what you mean by that? Or if you want to, like in the chat, or if you want to unmute, what does the can't divide by 0 have to do with the hole that's on our graph right here?
Unless I just remembered, like so basically in the bottom of the equation, so x plus 4, if you put -4 and you like simplify, it's 0 and you can't divide by 0,
Yeah.
which is why it's undefined.
All right. Yes. Y'all heard that?
Wow.
Look at that. Yes, that's correct. So that's why there is a hole here. So if you were to plug in -4 into your function, right? So if I was to plug in at least at the bottom, right? Let's just ignore what's happening at the top. If I plug in -4 for x at the bottom, you're going to get -4 plus 4. And -4 plus 4 is going to give you a division by 0 in the denominator. And you cannot divide by 0. And that's why your graph has an open hole in it. It's not defined there. So that's amazing that Henry, you brought that up. Awesome. I mean, I wasn't expecting that to be brought up, but that's really, really great that you made that connection. That's cool. Okay. Cool. Let me know if there's any clarifications on this. I'm going to move us into the next slide so that we can kind of now investigate. But remember, y'all, just because there was an open hole, I think who asked? Was it Janet? Somebody asked, like, does it matter if it's open or closed? Remember
Yeah.
yeah, Janet. So it doesn't matter if it's open or closed when it comes to limit. The limit can still exist even if there's an open circle. Because remember, we're like thinking, oh, the bug can't fall through it. So that's just a little clarification in case y'all are worried about the open circle. So let me clear this drawing. And let's go on to slide number 3, everybody. And let me make sure there we go. I'm going to move everybody to slide 3. There we go. Okay, so yeah, y'all are right. This function is basically not defined at x equals -4. Thanks to Henry's contribution, we know why now, because there's, you can't divide by 4. You can't divide by 0 because when you plug in -4, you get division by 0. So what I want you to do now is estimate what the limit is as x approaches -4 and explain what you did. So try to estimate it. Imagine bugs walking along here. What would you say is the limit? Again, if you're stuck, no worries. You could go ahead and put a question instead. Remember, this is all anonymous, so feel free to put what you think. So go ahead and take some time to do this. What would you think the limit is? All right, let me go ahead and take a peek at what we're having here. So again, we just got to touch on how to actually, touch on this lesson. If anyone wants to stay to discuss a little bit about our asynchronous number 2, feel free to. I'm happy to. Also though, on Khan Academy, you could put the ask for help, and you could kind of you get even the answer, and they go step by step. You can even put like why you were wrong and things like that, and you'll get full 100% full credit on your homework as long as you just try it out and check it out. But let's see what y'all are saying. So mentioning thinks the limit would be y equals -9, because you look at the graph and see that that's where the point is. All right, an agreement. This one, William says +9. So as x approaches -4, it's +9, since you could see the open circle giving off the point on the graph. -9, because that's where it seems to be at. I'm not sure, but maybe -9. All right, so a lot of you are kind of in the same boat, in the same thinking set. All right, feel free to finish off your last little thoughts on it. And again, for our credit today, it was the Padlet and us getting started on this. So tomorrow, sorry, is it tomorrow? No, on Thursday, we're gonna log back into it and kind of just finalize, formalize how we do limits using tables. That's gonna be our next lesson on Thursday. So here's our checkout, everybody. So let's pause here. You could go ahead, feel free to log out of your Desmos or keep it open, up to you. We're gonna go back to our Padlet for our checkout. And this checkout question is kind of going back into the big ideas we talked about today. For you, what must be true for a limit to exist at a point? Let me go ahead and put this Padlet back into the chat just in case you lost it. So we're again reflecting on those big ideas. Yeah, no problem. So you don't have to stay for office hours. You could totally look at the help. If you click on the I'm stuck or the get help on the Khan Academy problem, they'll show you solutions and you can see there. Yeah, no problem. All right, let's go ahead and complete the checkout. Again, you definitely want to make sure you complete this. Put your name or initial just so that I can recognize you. If you're uncomfortable with your initial, send me a text and you can let me know under what name you'd like to go by. Go ahead and complete our checkout. So we'll see what must be true for a limit to exist at a point. What do you know has to be true? All right, let's see. And then for this checkout, it doesn't have to be as long. It's just for you. Like, what's one thing you know that must be true for a limit? Awesome. I see y values have to be equal. I see the left and the right hand limits got to meet up. Both y values are the same. The graph meets up, doesn't have a gap, and the right and the left hand limit are equal. Those are amazing. They must be the same and should be connecting. I like that. Like the graph has to look like it's connecting. The function has to approach the same value, has to connect. Right hand and left, awesome. Need to approach the same y. Yep, and not leave a big gap, not be equal. All right, these are awesome takeaways and rephrasing of the understanding, like what's important for you all when it comes to knowing exactly when the limit does or does not exist. And then why values haven't be the same. Amazing, y'all. Go ahead and finish up your last thoughts there for your checkout credit. Again, so the credit is doing 1, 2, 3, and then just making sure that you met up with me up till slide 3. Let me make sure I, sorry, messed up. Yeah, there we go. I just opened it up so you have access to 2 and 3. I'm trying to figure out how can I add the first one too. Oh, there we go, like that. So that way you're able to log back in and finish something in case you haven't yet. All right, y'all. Thank you so much for your checkout and for your work today. I'm excited to continue.
Bye, Miss Adano.
Bye, August. Bye, y'all. See you soon. See you on Thursday. Or I'll see you in advisory. Bye. Oh yeah, my office